Alright. Alright, guess we're live. Sweet, sweet. Let me just make sure that everything's set up. Huh. Alright, cool. What do we got, guys? What do we got today? Huh. I don't know, I don't think anything here is that new compared to this morning. Is anyone else quickly losing confidence in Amazon? Let's see. Fake reviews, fake brands, zero way to report these listings. Positive reviews were for a pet cemetery headstone. The listing itself was posted by a seller that had almost all negative reviews. They were all calling the product a scam. Counterfeit items on Amazon. I think that's what they're just complaining about. Actually, you know what? I'm gonna see if Dota, if anyone's like playing Dota or there's any tournament going on. I don't think so though.
If you decide to stay in the closet for...
I haven't actually seen or played anything related to Dota in a very long time, actually. Yeah, I don't know. I think I've just been busy with like real life and shit, and like I haven't actually done anything. I think it's like, let's see, this week, half my week was consumed by DroidCon, so yeah. It's been I guess it's been kind of interesting, like just having basically my entire life just gets consumed by work of some kind or another. So I guess let's see. Wait, what the heck? Sniper's meta now? When was this? Looks like it's a carry sniper as well. Sniper BKB? Okay, I guess it's to block the Leshrac. Yeah, block the Leshrac, blink, and go. Yeah, this is so weird, bro. Oh, this is a carry profit. Huh. Alright, so you have Wind Waker on Leshrac. I don't know, is that the build? Because he got Blink BKB Hex. I feel like if you're in this situation, you actually go like Refresher, actually. You just Blink BKB Hex, Refresh, throw on Double Edict onto the sniper, just blow him up before he ever gets a chance to respawn. Because like once you turn on BKB, no one can stop you. And so wouldn't you want to like just throw everything to burst him down? Oh, there's a Shivas on the Timber Saw. Yeah, Leshrac's not gonna kill him. Okay, there's a Shadow Blade, Swift Blink. Interesting. Ah, man. Hold up. The quality on this is... let's make a source. Okay. Oh, he has Kaya Sanj. Oh, he has a Kaya Sanj already. Do you need Kaya Sanj? Yeah, I guess you need the Kaya for the Magic Amp. And Scotty on the Prophet. Yeah, this Prophet's friggin' stacked. Like, Prophet actually just gets a lot of stat gains actually out of all this shit. Hold up, let me turn on the sound.
It's with no trouble in the world. The issue is he can't get onto that high ground way. Because it's a sniper.
What the hell is this?
It's a storm. It's a Snapfire going semi-core. It's an Enchantress. You can also go semi-core with just a Hurricane fight. Like, there's a lot of scaling on Outsiders. There's a lot of high ground hold. They also can't go outside of their high ground, though.
Oh,
they can't siege. They have to contest the next Roshan for sure. But yeah, the rejects still have their Harpy creep watching Rosh. So try approaching that. That's going to be an issue. They will smoke.
Oh, yeah, the Storm Spirit's got to refresh.
We'll see if GPK will
this Storm
find
Spirit's
a kill
like...
here.
Yeah, this Storm Spirit got nothing.
Gonna move in, though.
Yeah, all he is just a zip pull, start the fight, and then hope the sniper blasts away.
Now gonna move in. GPK. He's been doing.
Yeah, I guess if you can isolate and kill the Leshrac at the very beginning of the fight.
They're gonna back off. It seems like they are well aware that something is wrong. And of course, in the meantime, Nature's Prophet pushes down the bot tier 3 tower. Surprise, surprise. Look at this rat.
I'm actually curious
look at the bot tier 3. It's gone. Raxes are gone as well.
Nice.
DM, he's trying to get there in time to defend this, but...
Backdoor kicked in.
Well, there goes the range rats. Who needs to fight when you could just split push?
Yeah, I guess that's one way. You know, if they dip out for the smoke, they make it pretty obvious with a D ward on the laning ward.
Okay, they took back
you have that opportunity to just rush your sniper's not there to defend. Treant can try, it takes a little bit more. And once Ramses hits level Turkey Mike times 2.5 HP on Treants, gonna be a bit of a process clearing that out as well for the sports, and even the Tim is gonna take a little bit more time in that. So still a little bit more left for the rechecks. We'll see if that opportunity presents itself once more.
I guess going
you have to be ready to have Pure come in for the defense.
Why
or at
not,
least have someone to take care of that push. You can't allow your racks to fall for free. Roche, 15 seconds away.
You're going to eat damage through Leshrac
eating it,
right? So why not just go for Satanic instead and try betting on survival?
All the extras loaded in there.
Because you already have the
rechecks just as their heartbeat creep. I'm surprised we're not seeing a heartbeat
unless
creep
you're like fast enough to dodge the Leshrac
link. Has the Centaur, but no flying creep of their own for balance here.
It's not like they can.
Oh yeah, guys, we'll start in like 5 minutes. I guess we're just kind of killing time. So if anyone has like questions or anything they want to talk about, just throw it in the chat. I'll answer them.
Yes, Ench needs a buff, if you ask me, John. Just make her creeps permanent. Look at this. Look at Ramses. This is what annoys me about this hero, John. You can just look at the tier 3 tower. But never mind that, because mid lane, they're going on FNG. Burrow Strike is there from Miero, but Vortex is out. GPK going to try and turn it as FNG. Dropping low, does end up going down. But they're losing their racks in the meantime.
They burned the refresh and the BKB, so actually they lose their ability to contest Roche.
What is this hero, man? It just doesn't make any sense. Ramses, he's going to BKB up. Just TP away.
Nice.
No problem.
That's hilarious. No way to stop the BKBs.
Oh man, you know what's funny, Mike? I've been I know it's a serious game. It's very close. That opens up a little bit of an opportunity for Roche from the rejects because they shove everyone back to base.
Okay, yeah. So well, top lane always pushing in. They are bot lane pushing in as well because of losing half the racks.
And outsiders aren't leaving the
just go for racks when not racks. You go for Roche on them when Undying is up.
They do not want to give Roche away. So it's a tough objective to contest. But again, that emphasis on Roshan is giving Ramses that opportunity, Mike, and it's something you see in your pubs. This happens to me every night with one of my friends. Except he goes Meteor Hammer and just dies. But he gets the push. You know, the concept is the same. Shove in.
Okay, they recognize it.
And if you're not at your base, what can you do? They've left their high ground. They're just allowing this to happen. Mid is not shoved in, and they will try for the Roshan. They do take care of the creep. Dropping low here.
Holy shit.
Yeah, they take the... Oh, they're trying for the Roshan, but they're in. They've got Miero, Pure. He's going to slap the Aegis away and just take down the Sand King. As they will find DM to boot. In goes the Press Kid. Just trying to get out of there with the Waker. GPK still trying to find a target, but in the meantime, Ramses, he's just split pushing once again, going for the Megas. Can he get it done? He's just going to BKB TP out. They can't stop it. It's just not fair. Mid lane, your Mitch is going to go down as they get another Scythe of Vice out onto the Enchantress. That'll be another.
It's fine. They just delayed the game by like 5-10 minutes.
I don't know.
You want something radical here, Mike?
I don't think it's like a push condition for
it's time for Batcher Sniper.
You have Aegis so much.
You need to stun Ramses when he tries to TP out.
Slay your base.
You've got the attack speed with a Mjolnir up. You don't need a Divine Rapier. You need a ranged Basher. 10%, more like 100% with enough attack speed there, Mike. Could be one way to stop it. Again, they go for the Roshan. They do take Aegis and the free Ags upgrade. So I'm not sure they pass that. They do pass it on to DM. You did manage to steal away the refresh here on the
even
side.
If
rejects, I believe.
You have that. There's still no way you go outside your base.
Santing Miero. So they do have a little bit more. You know, they take Roche Gold as well. Not the biggest issue, but the high ground. And I think at this point, outsiders will just stay there.
Look at Ramses. Look at it. Just here to drop the babies off, drop the kids off to school. See you guys later. DM will take care of it. Ramses, you know, he's playing a balanced hero.
Oh, okay. He didn't go for Arcane Blink. He went for Strength Blink.
It's only global.
Definitely not.
Not like it takes
Absolutely.
you off.
Nah. He gets a good snipe on Pure's Courier as well, which was trying to save again for that Divine. Has the gold. So he would have had that divine up soon, and just high ground hold forever. I mean, this is the point. Okay, so this is the point where outsiders will not leave high ground. They've got good wave clear with the Timber Saw. 2.5 times HP on trees doesn't matter. So they can hold on to these last racks forever. It's down to the rejects to find that opening. This is where it just stalls out, Mike. We're 10 minutes away. We might as well try to curse it. 10 minutes away from tier 5 items. We might hit that point, Mike. And we never do when we say that.
Very true, John. Thank you for that.
Oh, okay, Sniper actually got a rapier. Alright.
In some sense. Pure.
I don't think it changes anything,
the
though.
divine up now. Here's the thing, though, John. It doesn't feel like damage is the problem for Pure, because, you know, you can't
if he gets
fight
hexed,
the profit
it
anyway.
doesn't
He's not
matter.
playing for the fight.
If he gets blink hex, actually no, he has the Aegis for insurance, but once he gets blink hex, once that expires, he does nothing.
I liked your bash idea, though.
Yeah, I mean, that's spicier. It's also maybe less smart. You know, you could probably just kill the NP. It does have a lot of HP, though, Mike. Around 4k with 33 armor. So I'm not sure if you actually have enough with the Divine to plink him in, say, 3 hits, 4 hits. Although he does have pretty good attack speed. Yep.
We get that. We get the live frog reaction once again, 15. Can I just have a look at how the frog's reacting right now? Just need a. No, we're not going to get it? Fair enough. We'll wait for the next one. No. Okay, thank you. We'll wait for the next time around.
One asks, is my job secure during this recession?
It's,
I mean, I would like to think so, but, you know, nothing's ever guaranteed.
Again, push your lane.
I think based on what I have seen at BoardCon, there are some companies that are hiring like crazy, like Tinder, and other companies that are rescinding their offers like crazy, like Coinbase.
For a little bit. This could make or break them.
I think I'm pretty okay.
It might not work.
You know, I don't anticipate anything, but
that's a great burrow strike, Miero. Oh, no. He sets up perfectly. GPK, he's gone. The leash up the Timber Saw DM. He's gonna be all right. GPK though, he bought back for this. He wants a team fight.
No, that sniper needs to get out the fuck out
He'll
of there.
be targeted, but he's fine. With the Aeon Disc, he's gonna be able to get himself out.
It's 8 p.m. Let's bring my client on and see what's up. Yo, hello? Hello?
Hello. Hey,
yeah.
Bert.
Hey, I can hear you. Can you hear me?
Yeah, I can hear you. I can hear you.
Cool beans, cool beans. Yeah, how has everything been with your practice? I know we talked on Thursday, but...
So I tried improving my practice diary,
sort
of. So now, like, whenever I do my delta, like, when I do my delta, I try to, like, put ways on how I can avoid the same mistake, sort of thing. Instead of just stating like the mistake that I made. So yeah, that's basically what I've been doing. I tried to make my pseudocode a little bit more, well, my high-level description at least a bit more descriptive. So like, I basically just, for the more recent problems at least, like not the DP ones, I just say like at each step we do this section. If it's a in the recursive definition, and when it's recursion, when it's a recursion function, I basically say at each step we do this, and then we recurse.
Okay.
Sort of thing. So like we know technically at each level what we're doing, and that's generally enough knowledge for me to go off of to implement the algorithm. Because after that, it's just handling base cases, which I state usually in, which I usually say or I type it out.
Okay. I see. Yeah, I'm looking at your practice diary right now. I'm guessing I'm gonna start from like row 120 or below that.
Row 120. That's like, you can probably start at after our talk. I think I was at row 107.
Okay, so you actually did quite a bit.
Yeah, okay, so 108 is what I started with after our talk.
Okay, I see. Yeah, I see the code. Tabulation, How do you feel now that you've done, like, some dynamic programming problems?
I mean, I feel okay with it. I'm pretty sure, like, I haven't encountered anything else, any DP questions outside of grokking, so I don't know exactly how I feel about it. Because I feel like there might be more stuff nuances I still don't understand, but... Generally, I feel like if I can fit it to, I know like some patterns for it. I know like a general structure and how to think about DP now, more or less.
Okay. Yeah. Let's review your practice diary before we jump into a problem.
Yeah.
But it seems like you got through like 100 problems already, or 100 problems plus. I think you should have started getting a hang of like the flow for being able to approach these problems. How do you feel now, like compared to like, I don't know, let's say a week ago, when it comes to just doing problems in general?
Yeah, a lot better. Like I feel like I understand like a lot of stuff than when I initially did everything.
Yeah.
Like my practice. Like now I feel like I understand. Oh, they did this because of this. This makes it cleaner because X, Y, Z.
Mm-hmm.
And yeah, like I feel like I understand like why like solution handbook usually come out the solution they do, and I try to like think about how they do it, sort of thing.
Got it.
I remember at least before we even started our practice sessions, I could not solve like n queens at all, sort of thing. But now like I more or less understand how they like the logic through it. And yeah. But I do feel that now, like, cause the past few days I've just been like doing DP problems. I feel like I might have forgotten some stuff because now it's just like I've been only solving DP problems.
The thing is that the approach is still going to be exactly the same. What's the naive solution and optimize over it? That never changes.
Yeah.
So believe me, if you did it right, and we'll see today, you should not forget this. So let's take, you should not forget like all the stuff you did in the past. So let's take a look at this. 15 minutes for high level description and naive solution. This is the minimum number of jumps to reach the end problem. Okay, let me pull up. Let me pull up the.
So EPI. So I thought that question sounded familiar. EPI is a similar question to that in the array section.
Yeah.
And then this variant of it.
Okay.
A variant question in EPI. So I don't like that. That was just like a nice thing to look at.
Okay.
But I didn't really know it until after I did this question.
Okay, you're saying that there actually is a similar problem to this in EPI. Okay.
Yeah.
Here, wait. Let me log into into my grokking, so just to make sure I understand exactly what's going on here.
Yeah, for sure. It's basically like you can summarize it as like the can we reach the end problem. It's basically you can summarize it as like the solution as long as you're making progress, you can reach the end eventually.
Oh yeah, that's true. Oh yeah, so you have an array of like all the different number of jumps that you can take.
Yeah. And like each number represents the maximum jump you can take at that point.
Yeah. Okay, so my question is, okay, let's take a look at this because your runtime looks a little funky here. Why is it n? It shouldn't be n squared for a dynamic programming problem.
Wait. I did type in n squared.
Yeah. Why? It shouldn't be.
What do you mean? Isn't DP problems usually n squared sort of thing?
No.
I mean, not usually n squared, but
What? It's not. Remember, you have to do this step by step. Don't fire off the fucking thing. Prove it to me. Because if you look at your code, let's assume for the sake of argument your code is right, right?
Yeah, okay.
So walk it through me. Tell me how it's n squared.
So it's n squared because at each step, so like pretend we're at index I, we try up all jumps. Wait, let me read my pseudocode again.
Yeah, read it. This is not the and the naive solution would probably be n squared, but what I'm saying is, well, your optimal solution should be just an array. So how can it be n squared?
Yeah. Okay. Okay, so it's n squared. Okay. Let me highlight my DP problem so I can actually focus on that instead of the naive one and memorize. So yeah. Okay. So it's n squared because basically at each point I try to see how far I can get from that point, and then I try all possibilities from that point.
Let me pull up something doesn't seem right. Something's not right here. And
like pretend like at a certain index it's like 5, right? So I basically try all indices up to 5 plus the current point I'm at.
Yeah, I understand that, but that doesn't sound right. That does not sound like the right solution to the problem. I mean, it's probably a solution, but it doesn't sound like it's the optimal one.
Yeah. I mean, it's not the optimal one.
But the thing is that, okay, but the thing is that you should have come up with a optimal solution. That's my problem.
I think if I were to do this separately, sort of thing, I know from EPI, there is, I can solve the if I can reach the end, it's O of n if I can reach the end, because at that point it's basically like, oh yeah, you know, just take the max of each number that I encounter plus the current index I'm at. So if I reach the final index, then okay, I'm done. So that's essentially O of n. But then if I wanted to find the current minimum jumps, I feel like whenever I reach the end in my current vertices before incrementing the next jump, before proceeding to the next jump, see if my current index is the current max I've encountered so far, and if it is, increase the number of jumps I have to make by 1.
Okay, I see why you think that, because you have this range n equals 1. Oh, and by the way, when you're explaining your solution, you gotta be a lot more precise.
Yeah.
That's a problem. Okay, but yeah, I understand what you're trying to do here. You have a minimum jump helper, for in a range in n-1. The furthest you can reach is each one of those. Then dp end. You evaluate dp end or dp start plus 1.
Yeah, because start is, you know, that one.
I understand, yeah, but this is what I'm thinking is weird. This doesn't seem right. Hold up, did you compare? I know Grokking has the ability to run the solution. Did you actually run the solution?
Yeah, I ran the solution. It works.
It works. And
but
okay, so they do have a time complexity and space complexity of order n. Okay. It just didn't seem right to me, but let's see.
No, your intuition is right. Like, it's not the most optimal solution.
Yeah, but I mean, like, the book said, I mean, like, they're saying that they have a time complexity of n squared. So I'm like, okay.
I feel like I got roped into this, like, algorithm, because, you know, since, like, doing the previous problems, the pattern, it got me, like, fresh into thinking, like, about this specific pattern sort of thing. Mm-hmm. And then, you know, I just latched onto it, like, oh, easy solution to try out. And then I memorized it and I tabulated it, and then I was like, okay, there's not many stuff I can improve on tabulation after bottom up, to make it sound.
Yeah, I understand what you're trying to do here, and I think I'm trying to think, is there a faster way of doing this, and I don't think so. So I think you're right about the n squared. So it seems like, I know they call it, like, memorization tabulation, but this seems pretty straightforward, actually. So okay, it's fine. Give me one that you. I'm looking at this. 2 ends are equal. So let me look give me one that you think you kind of did, like, kind of shitty on.
Yeah, I think most of my problems come from trying to actually make the tabulation solution. I know one I struggled on was oh, let me take it back. Let me look at the. I know I had typed out. Okay, couldn't come up with tabulation was the longest increasing subsequence, but now that's like row 119, because I couldn't come up with the tabulation method.
Okay.
It's let me find out another one. I think another one would be that one.
Let's focus on one for now. Let's focus on this one.
Yeah.
For now. Yeah. Okay. So longest increasing subsequence. I think longest increasing subsequence. Let me pull up the problem. Yeah. Okay, so I have it on Grokking. Given a number of sequence, find the length of its longest increasing subsequence, and in an increasing subsequence, all elements are in increasing order from lowest to highest. Okay. So it's within this string. The longest increasing substring of 4, 2, 3, 6, 10, 1, 12 is 2, 3, 6, 10, 12. Okay, let's see how you do this.
Yeah.
Okay, so couldn't come with tabulation method. So at each step, if the current number is greater than the previous, increment count and recurse on the rest of the array. Why recurse?
I mean, you know, this is like essentially a recursive function. I should have specified it a bit more, but you know, I recurse on the rest of the array because I need to find out the rest of the increasing subsequence. So basically, starting at current number as previous, because the current number will now be the previous number. So find out, if there's a longer subsequence. no, longer is subsequence, right? Yeah, a longer subsequence that utilizes this current subsequence.
Okay, I mean, I don't think you need recursion for that, but okay. Cause
I mean, it's just an easy way to think about it.
Okay, yeah. So let's put our 5-year-old hat on for a second. And it says, let's try to read this. So at each step, are you So what is each step? You mean are iterating through the array, right?
Yeah. So essentially, while iterating through the array, at each step, do this.
Yeah. So no. Remember, you're skipping details.
Yeah.
If I'm Anya fucking Forger, do I understand what the fuck you're talking about?
Yeah. Okay. So I think it would be better.
So if the current number is greater than the previous one, yes, that's fine.
Yeah.
Increment the number. Increment the count. Count of what?
Okay. Yeah. So I should have specified.
This is what I mean by you need to review your work and just I was like, did you say that hey my pseudocode is shit? And I don't see that. So yeah, this one you need to really review your work, dude.
Yeah. Okay, yeah. Increment count of longest increasing subsequence. So just LIS.
Okay, yeah. So longest. So you can say the current run or current candidate run or something like that.
Okay, yeah.
For LIS or something, and then recurse on rest of the array. When you say recurse, we have to define what that function is you're putting in and what you're getting out, right? So recurse doesn't mean anything until you define what your recursion is.
Okay, yeah. In this instance, recurse, I just mean increase the index, and it'll return you the longest increasing subsequence using current number, the current number as the previous number.
The current number, you mean the current index you're looking at as the previous number?
Yeah. So the current index we have now becomes the previous index. You know, because we start now comparing the current number to later numbers.
Okay, so you have the longest subsequence within that array, and then you return back that actual sequence. Is that what you're saying?
No, we return the number, the length of the.
Okay, you return the length of it, but then you're not guaranteed that that substring is continuous with the previous index.
Yeah, I mean it's a subsequence. So since we recurse on the array, we recurse on the rest of the array. We know it at least is after the current number.
Okay, it's a subsequence. It's a subsequence, right? Okay,
yeah, it's a subsequence,
not continuous. Okay.
Yeah.
That I understand now. Okay. It's not substring. It's a subsequence. Got it.
Yeah. I mean, if it was substring, then technically, I could just do one for loop and just, whenever it breaks, I just make the count 0.
Got it.
Or 1.
Okay. Yeah, you need to be a little bit more descriptive with this. So that could be one reason why you didn't come with the tabulation method. All right. Otherwise, return the maximum skipping the current element and keeping previous or skipping current. Return the max of skipping the current element and keeping the previous what?
The previous element, essentially. Like it was.
Really? Element, or do you mean previous candidate or the most global max or whatever?
No, previous element because because basically it's previous element.
Okay.
Yeah.
Okay. All right, so fine. So then let's ask ourselves, what's the state that you can reuse here, and what are your decision points?
So, I mean, the ones that I defined, I can think of are the current number, like the current index we have, and the previous index we have, because those are the only changing ones, and then with the indexes, I can get the actual number in the array anyways, so I don't need to keep track of the numbers.
Okay, that's right. You only need to keep track of the number, and then the current. Actually, there's the index here. It's because you only have to keep track of maybe index I versus I plus 1. If it's not increasing, then you can ignore it. So that's going to be one of your conditions. And then the second one actually is going to be the longest subsequence that you've seen so far. Do you understand why?
I'll say that again.
The other one is going to be the longest subsequence you've seen so far.
Yeah.
So the thing is that you say max of So this else statement is really your decision point actually. But anyway, you get the idea. So let's see. So let's look at the code here. So now that you identify that, then you know what your 2 dimensions are already. So actually, you only have 1 dimension. So your DP should only be 1. You should only have a 1D dynamic programming thing, because you don't actually need to. The reason why I think I understand why you did 2, but I think it's wholly unnecessary. Do you understand?
Yeah. Yeah.
So.
I didn't need to use the previous because I could have just kept track of that in another variable sort of thing instead of using previous.
You can just evaluate it as is because all you really care about is the number before that, right?
Yeah.
I mean, you can also do double loops as well. So let's. I mean, I'm not gonna pound you on that because you kind of ends up being like this. I think it comes out to be the same thing, but.
Yeah, like I know when I looked at the tabulation solution, it only used one index. I mean, like one D array, because it removed the need for previous.
Yeah.
By utilizing previous states and all that.
Yeah, that's why I think the previous index is actually kind of useless here, because it's like if I'm comparing I to I minus 1, that's pretty much what I need to consider. Because there's no reason for me to consider I and then I minus 2. That's already disjoint.
Yeah.
It's like it would. But anyway, you got 2 carbon framework solution bottom up. Okay. Other than that, I think it's okay. But it's fine. It's fine. Dynamic programming is not going to be asked too often. Anyway, so okay.
I mean, I hope, because apparently DP might be one of Google's most common questions.
Yeah, the Google or LinkedIn will ask you that actually. So anyway, with that, let's actually go ahead and do a problem. I think your diary entries are a little bit sparse. Got 2 carbon the framework solution. Need to consider. Okay, yeah, let's do a few problems together. Because I'm curious to see like how you're gonna do this.
Yeah.
But yeah, like I said, you kind of need to be a little bit like I said. If you look back at your own diary and you find issues, you gotta address them.
Yeah.
No, not yeah. I mean, you really.
Yeah, my bad. Okay, I'll look over my diary entries after this. Starting from the ones that I started yesterday, and then add them up. Add them if they turn out to be pretty if I misunderstand something.
Yeah, then that means that your feedback is shit.
Okay, yeah.
All right, so let's go ahead and open up the problem sheets, and then let's go ahead and pull up a problem. I think I gave you this problem last week, but now that you have to know dynamic programming, you should be able to do this one.
Okay.
Oh yeah, I did give you this one last week actually, but now that you know the dynamic programming version of this, yeah, literally the exact same one. But don't look at the bottom sheet. Okay? Don't look at the below it. Okay.
Okay.
Yeah, you don't look at it. Just don't look at the solution. Just there's a dynamic programming solution to this, but let's see if you can get it. Oh, actually no. You know what? Fuck it. Since I feel like I just biased you right there. Let me give you another problem I fucked up. Ah, man. No, not this one, not this one, not this one, not this one, not this one. Not this one, not this one, not this one. No, actually, yeah, no, you know, fine, fuck it, since, screw it, let's do it anyway.
Yeah, sure.
Yeah, screw it. Alright, and let me bust out the timer. Like, even if I realize, even if I bias you towards it, this has never been asked in, like, a, like, grokking or anything, so I might as well just roll with it.
Okay.
Alright, let me get out the timer. Cool. And then... here we go. So, given a set of positive integers, find if it can be divided into 2 sets with equal sum. So 1, 2, 3, 4, 5 is a total of 15, which means it's not possible to find 2 subsets with the same sum. So go right on ahead.
Okay, so let's try to. Let's try an example to find out how to the possible subsets for the example. So this. Okay, no, that's fine. But yeah, okay. So 1, 2, 3, 4, 5. The total is 15. They already gave it to us. It's not possible to find 2 subsets with the same sum. Why is that? I'm guessing. Well, not guessing. Okay, so it's not possible to find 2 subsets with the same sum because if we divide this by 2, it's like it's an odd number,
Okay.
right? So it's an odd number, so you can't really split an odd number into, you can't really split an array into two odd numbers. Two odd numbers do not equal an even number, is what I'm saying. So let's move on to that. So we now rule out sets with odd sum.
Okay.
So now let's find out an even sum, how we can separate it. So basically for the same, we're just gonna use the same one, but just remove the 1 to make it a even sum.
Sure.
So that would be 14. So that will 10, 14. Yeah. Okay. So yeah. So now we let me change that so I don't confuse myself. So yeah, if we divide 14 by 2, that equals 7.
Okay.
And if we divide the subset into 2 equal subsets, if we divide the set into 2 equal subsets of sum 7, then we can find 14, which is equal sum. So 2, 3, 4, 5. Yeah, let's find out a possible subset for this. So basically 2, 4 and 3, 3 and 4 would be 1,
Yep.
and 5 and 7.
Really? Don't you mean 5 and 2?
My bad. 5 and 2. Yeah, my
Okay.
bad. Yeah. Okay, so is there any possible other ones? 5. No, they're just the same order. Yeah, I mean just different order, but same numbers. All right, so I guess that will be 1. So now, essentially, a solution that we can do is at each step, we can either take the current number and consider it for our subset, or either just don't take the number for a subset. And we take the sum of those sets and equal it to the sum divided by 2. So let me write that down to make it a bit more clear. So, find a set that has, find a subset that has sum of set sum divided by 2. So that is the high level of what we're doing. So at each step, we create a set that includes, that takes, that's probably a better word, that takes the current number if the current number is less than the sum.
Okay.
Because, you don't want to take a 15 when it's only a 7 or something.
Sure.
Yeah, and then create a set that skips the current number, essentially, because this is our don't take the number step.
That's fine.
And then let's test it out to make sure it looks okay. So just write it down again. So we have 2, 3, 4, and 5. So essentially, let's create a set that takes 2. A set that doesn't take 2, that's kind of empty. Now we go to the next number. So 3, generating from the previous solution, that's 2, 3. And then now that's 3 over here. We're just going basing off the previous iteration, the top 2 ones we have, because if we do more, it's gonna be around a lot of recursive calls and mapping out. So we're just gonna go for one of the top 2 ones and basing it off of those. Okay. To see if we can find a solution. So 2, 3, that's equal to 5, right? So that's 5. Let's go for our sum. Let's update our sum a little bit. So it's supposed to be 7 minus 2 minus 3. So that's currently 5, 2. Okay. So 5. Yeah, so that's currently 2. So you already know that's sort of a dead end already, because if we go recurse onto the next number, that's a 4. That's obviously not suitable.
Well, here's the thing. You can't assume that the array is sorted. I just did it for convenience.
Yeah. I'm not assuming it's sorted. It's just that every step, we check if the current number is less than the sum. But from a high level view that we can see that 2, 3, 4, 5, the rest of the numbers can't take, so we just won't continue writing it, so it saves some time. From mapping it out. So 3, 4, you see this is also one of the current ones. We skip that comes from the steps that we skipped the current number, the first number, and then we added the second number that we saw. So going from that, you know, we also create another set that skips 3, and now you curse on this again. The rest of the array, it's 4. That equals 7.
Okay, that's fine. Yeah.
Yeah. Once you find it equals 7, you know the other numbers are just gonna equal to 7 anyways.
Sure.
So, you just use this set. It equals to 7. You're good. You use the other numbers if you want to recreate it.
Okay.
So after that, return the set that has the sum of sum divided by 2.
Okay.
And now let's.
I'm gonna say, all right. It seems like you have a pretty good naive solution. You want to code that up first?
Yeah, sure. Yeah, let's code up the naive solution. So, let's define it as the function as can subsets. Okay. No. A better word would be partition subsets into two equal subsets. Partition set into 2 equal subsets. Set into 2 equal subsets. Okay, so yeah. You know, obviously we take our set, so let's just name it nums. After that, you know, yeah, that's all. That's the only thing we need. So, and then after that, you know, we define a helper method to actually do the steps we need.
Sure.
So, let's first, before they do that, we define this. We need to get the sum of it. So just sum nums. Let's just name it total. After that, and then if total is not divisible by 2, you know it's already false.
Sure.
Return false. Yeah. Okay, and then after that, we just return our helper method. So let's just define subsets helper, and pass in an index essentially.
Sure.
Yeah, because we only need an index and the current sum.
Yep.
Which we'll be keeping track of. So after that is define subsets helper over here.
Sure. Index.
I'm just gonna use total again.
Okay.
Now this is our check. Basically, you know, these are our basic checks. So if we finish traversing the array, you know, we're done. You know, really don't do anything.
Fair.
Now, basically, this is a good step to take. Now, if our current total is equal to 0, then return 1. Return true, essentially.
The thing is that you have a return 0 at the top, so...
Yeah, my bad. Okay, return false. Yeah. I should have specified that a bit more.
Okay.
I noticed in here, we forgot about that. Divided by 2 because we're only trying to find the equal subset sum. Also in here, we should do it beforehand.
Okay.
We check the false because, you know, what happens if the last number is equal to the total? Then, like, n-1 index. That's what I mean by last number. If that equals to 0, it won't really get caught in our exception.
That's fine. Well, I get it. Yeah, you don't need to ramble on. I got it.
Okay. So yeah, and now is that each set, create a set that takes the current number. Then the sum, and create a set that takes a certain number.
I only care about true. I only honestly care about true or false at the end of the day. So.
Yeah. Okay. So yeah. Subsets helper. Index plus 1. Total minus the current number. So index and this is without num, so subsets helper index +1, and total stays the same. And then you basically just return with num or without num.
Sure. Okay.
And that should be our general solution on how we tackle. Forgot to put in one piece of my pseudocode. The if current number is less than the sum. So if
Sure, that helps.
Yeah, just to help, so we don't actually. Because if it does, then I have to change this base case to less than or equal to 0. So we don't want that bug happening. So total. With that, I do have to have a high level variable, so false. And yeah, that's how it'll go, essentially, for our naive solution.
Sure. Now give me the optimal one.
Okay,
well, first of all, yeah, give me the optimal one. You know this is not optimal, so.
Yeah. So
or
one
actually,
of the
this is optimal technically, but just dynamic program. You know what I'm asking.
Yeah. So I mean, in Python, there's a really nice thing that does it for you. You probably don't want that. Func tools.lru cache that technically just caches everything for you. But I don't think you'd like that because it does all the DP work for me. So let's go for the actual. Let's go for actually creating the subset solution.
Yeah.
So over here, let's find out what states we can reuse. I know an index from our recursive function. The obvious ones are index and total because if we ever reach a same index with the same total in our recursive calls, then it's the same solution. And you can see from here that we either without num or with num, we can reach the same total many times and also the same index many times. And they'll coincide too at certain points. So yeah, essentially those would be your states. So over here, it'll essentially be a 2D array with the sum and the total.
Okay, that's fine.
So yeah, so over here, let's initialize the DP array. So DP array will essentially be the total divided by 2 plus 1. You get, that's the order of operations. The same for that.
Okay.
So yeah, and then n. Not n. Yeah, n. I have n in here, right? No, I didn't define n. N equals length of nums. So yeah, over that, essentially now I basically just do the check over here. The memorization comes after the base case checks. So if DP index in total is equal to -1, not equal to -1, we essentially just return the current coordinates.
Let's stop for a second. I am asking for true false only.
Yeah, my bad. I should have put false.
Okay.
False. Return index total, and then basically after that, we set, instead of returning, we set our current index, our current coordinates to the result, and then we return the result.
Okay. Okay, that's memoized. So then now, you want to give me a little bit cleaner solution?
Yeah, sure. So a cleaner one would be using tabulation, which is the bottom up. So we first define our base cases and then start iterating from those base cases to the actual solution.
Sure.
So to that would be, that would be the same DP array. So let's just comment this out so we know not to use it again. And the rest of the solution comes from it. So I'll be recording after the DP array initialization. So we know our base cases are when the number is 0. So we know when the index, we know from our memoir solution that the first row of our DP array is going to be the result of whether the number is equal to the sum at that point, the total at that point. So let me iterate it. Let me say it again, but in writing.
Okay, yeah.
So at each index in our DP array for bottom up, create if the sum can be made from this index, this number or previous number, set it to true.
Okay.
Yeah, previous numbers. Okay, no, at this sum can be made from taking the current number, create number, or skipping the current number, then it becomes true. Essentially, it's just reiterating over the high-level description that we had before each step.
That's fine. Yeah, go ahead. Just do what you need to do.
Okay. So yeah, over here. Now let's go through all. Let's set the initial cases for our DP array. So over here, iterate up to n. That the initial ones. That the initial column is going to be false because a sum of 0. Well, no, a sum of 0 is just you don't take any elements, so that's true. Now over here, let's iterate over the first row. So for t in range total, for simplicity's sake, let's just equal total to be divided by 2. So yeah, now in total, we just do the first row. So if dp a 0 t, it's only true if the number is equal to our total. So nums 0 equal to t. That essentially gives us a true or false at each point in that first row. So now let's go to the actual DP array now that we have our base cases handled. So for I in range, n, for j in range, n, no, total plus 1. And now it's the with number without number. So basically if the current number can be taken, so if so if dp I minus 1, that's our previous number, and minus the current number that we have is true. So that's, yeah, if the current number is true, then we can also make this true. So okay, there we go. True. Just making sure again. Else if nums and I is less than our j and that lf, basically our we can already make the sum using previous results.
Okay.
Equal true. And after that, essentially is just return the bottom right index of our DP array, because then that means we iterated over all possible indices and sum ranges. So n minus 1 and total.
Okay, let me double check this because you.
Yeah.
Okay, so I in range of n. So when the sum is 0, you're saying that all these numbers can't. You're saying it's true.
Yeah, because I can make the sum of 0 with no numbers, so that's technically true.
Well, 2 sets. The question asks for 2 sets. So if I have one set of no numbers, the other set must have all the numbers, and you're automatically saying that the sum of all those other numbers is true to 0?
No, like the empty set of both. Okay, no. Okay.
How can you divide a set of 2, 3, 4, 5 into 2 empty sets?
Okay, yeah. There's only one. Okay, you're right about that.
So I feel like you had no. This is yeah. That's not right.
Okay, yeah.
So then now you have t for your sum if the element, or the first element of sum is equal to t.
Yeah, basically it's our first number is equivalent to
Well,
t.
again, if this example, if my target sum is 2. Oh, actually no, they can't. T in range of total. So you're looking at every single number between 0 and
the total.
And the sum plus 1.
Yeah, because we need to include the actual sum too.
Okay, but in this case, you're looking at all numbers between 0 and 15. Or no,
7.
14, yeah.
14, yeah.
So in other words, you're making this true if the number is 2, 3, 4, and 5?
Yeah.
So you're saying that would imply that
I mean, this is just for like a total of 2 though. We're not done the current array at that point. Right?
Oh.
So basically, for total of 0.
So if I'm looking at, so you're saying that if I have my first, so in other words, let's say that because your first index is your position and t is your sum, right? So in other words, for all numbers between 0 and 14, I'm gonna see like 2, 3, 4, and 5, right?
Yeah.
So you're saying that that dp of 0 and 2 is true.
dp of 0. Yeah.
So you're saying that if I only considered a set of 2, that I could split this into 2 sets of equal number of equal sums?
Yeah. So at that point, we're only considering index 2 though. We're not considering we're pretending we don't know what 3, 4, 5 is.
Exactly.
As of right now.
Exactly. Yeah. That's my point. You're saying that if we only consider 2, the first element, that I could split this into an array of. I could split this into 2 equal sums?
2 equal sums, 2. Okay, I mean that. Okay, I think the first assumption was cascading to the other ones because I assumed the empty set was technically a valid subset.
Or are you saying that this doesn't even make any sense at all?
Okay.
Like no. Tell me, because you said dp of up to I just means you're considering all the elements up to that ith index, right?
Yeah.
So in other words, and then you have your sum on that axis, right? So this would be dp of elements up to I, and then this one would be sum, right?
Mm-hmm.
So you're saying that if I had elements if I had that array, right, elements of 2, and a sum of 2, I could divide this into 2 sets that equal each other.
Yeah.
Does that make sense?
That doesn't make much sense.
No.
No.
Anyway, I think there's so this one is just completely wrong, I think.
Okay, yeah.
Okay. So, all right. I can see why you're struggling. I know what's going on here. So delete that. I'm also just I'm going to stop the timer because I can see what's going on. Basically, okay. I know why you're screwing up on tabulation.
Okay.
The bottom line, actually, I'll give you this. Do you want a chance to fix all your shit, or do you want to go straight into the analysis?
I mean, we can go straight into analysis for time's sake. Yeah.
For time's sake, basically what I saw was that you were fine for doing all this up at the front. Where you started screwing up was when you threw away all your work. Do you understand why I'm saying you threw away all your work?
I guess it's because I didn't base it off of my memorization solution too much.
Yeah, no, you threw it all away. The whole point of memorization is to give you that, basically, it's the key here is this, right?
Yeah.
I don't see it at all in here. That's why you screw up on tabulation. You're not reusing that same logic.
Okay, yeah.
Because you made that as your decision point. You made that your branching factor, right? You know what? How about this? I will show you an answer, and you're gonna slap yourself and just say, "Holy fuck, that was so simple." So, let me do that.
Okay.
Down here. Let's look at this. This right here is literally the exact same shit up here.
Yeah.
And it's simple. All you have to do is just start off with this, like, hey, the number is less than the sum, then blah blah blah, whatever. But then this is the real meat of it.
Yeah.
This is what you needed to write. I don't know what the fuck this is.
Wait, isn't that your the code you pasted? What do you mean?
This is the one I highlighted orange. I don't know what the fuck this is.
Oh, there. Okay. That one, yeah. Okay, yeah.
All you needed was like you said. All you need to care about is like the pre-populating. This one already pre-populates and assumes that the numbers is either take or not take, right? And this one is this one is either that's where it pre-populates, right? And then it does this here. It's either you don't take it, which is just whatever you had in the previous value where you ignored the index, and if and like you said, if the number is less than j, then you compare it to if you were to take it, which is right here. So this one is don't take, and then this one is take.
Take. Yeah. Okay.
This is why you're screwing up tabulation. You threw out all your work.
Yeah, I'm not reusing the old work I used.
I am very certain that we've talked about that one before.
You mean by committing to the solution?
Throwing away your previous work. I mean, I'll give you some forgiveness because you're not used to seeing it in DP, but you made this mistake again.
Okay.
So that's why you're not getting tabulation. Other than that, like, your logic was, like, literally sound all the way through. I didn't like the fact that you kind of, other than that, like, I get why you did this. A few other things. That when it comes time to the actual interview, you should do this. You should be able to do this one in your head when you talk about the caching. And you should also be able to do, like, the naive code. I don't mind you writing it because some interviews might ask you for that. And I noticed, like, you had a few adjustments, which is fine because, you know, but basically in the actual interview, you're not going to be asked to actually write the cache code. And I think that for some point, I think you kind of got a little bit sidetracked on this, which is fine. You came with an answer anyway. But the point I'm trying to make here is that once you get this, like, naive solution, you should immediately know how to cache it. And you don't need to write the code for doing it, and you should immediately jump to the DP solution. Okay. It's about being faster at it, and being able to and in order to be faster at it, you have to reuse your whatever the fuck you had here.
No, go first.
Yeah. So let me paste my notes in here. So you had so a few things. One was I mentioned that hey, with your recursion, you needed to find your inputs and outputs. Remember, and I remember I had to correct you on hey, you returned 1 here. But you're returning false on the other one, and you kind of said, "Oh yeah, let me fix that." So basically, I already said this, at 4:52. I already identified that this might have tripped you up, and it tripped you up. So be really careful about your recursion. When you want to use recurse, you can't wave a magic wand recurse unless you define what you're putting in and what you're getting out. So let's make that our rule. You are not allowed to say recurse until you define what the recursion function takes in and spits out. So let's make that our rule. Sorry, code naively. You fucked this up. LFMAO. Good catch on the 0-0. Yeah. Other than that, I think if you can actually just jump straight to this shit and ignore and not have to memorize it, and you didn't fucking throw away your work, I think you could have easily gotten to 12 to 15 minute run, 12 to minute solution. Instead, it basically took you 20 minutes.
Yeah. Okay.
And you didn't even get it right.
Wait, yeah. I'll go say that again.
And you didn't even get the DB solution right.
Yeah.
So.
Yeah, bottom up. I mean, so the top down was okay. The memorize was just a little bit iffy, but in an actual interview, I just go to the recursive solution, and then I just I can basically map out the recursive solution, write it out as a high level, and then go straight to the bottom up solution.
Yeah. Because the reason why is that when let's take it from my view of the interviewer, you're adding this one here, you're adding this, and you're adding this. To me, that just says you know how to use a cache. That doesn't tell me you know how to actually write the DP solution.
Okay.
It's like, yeah, you know where to cache it. You know along what axes to cache it on. You don't need to say this. I mean, you don't need to write this out. You can say it, and then just apply it to your actual solution.
Okay.
So, that's what I mean. Does it make sense?
Yeah, yeah.
All right, now you know why you're screwing up tabulations, because you throw away your previous work. All right.
Yeah.
Let's do this. If there's no other questions, we go straight to the second problem. I mean, I don't need to repeat myself, but unless you feel like some points need to be clarified.
Yeah, I think everything should be clear.
Okay.
Yeah, reuse old work. If I can map out the recursive solution pretty good, then I can jump straight to the bottom up, because the memoized solution for just recursion is just telling the interviewer I know how to cache instead of knowing actually how I can DP.
How you can solve the problem, yeah. Remember, everything you do, everything you say should be in service of advancing the discussion of the problem. I know you go on a lot of different tangents, but really try to catch yourself and I guess rewatch this interview, rewatch the session, and say, hey, how many times did I go off on a tangent that was completely irrelevant?
Okay.
And it's like, really be mindful of that. Every single word, every single action you do needs to advance to the solution.
Okay, yeah. And then, so basically I can just state some logic, and then if the interviewer is confused, should I ask them about it? They'll ask me about it, and I'll go dive deeper into that line of logic.
Yes. So the whole point of why I make you do things step by step is that way, in case now that you should have a little bit more solid grasp on it. Is that in case you can go faster, maybe skip some really obvious steps, but just in case, humans are imperfect at this, right? So in case you jump something that the universe says, I don't get it, you can backtrack and just go step by step in the details and be able to guide them through it, like they're a 5-year-old child.
Yeah.
The opposite of this is just jumping steps and then losing the interviewer, not being able to recover the interviewer, which is what most people do.
Okay, yeah.
It's like when the interviewer says, I don't know what the fuck you're talking about, that means you have to backtrack and explain something.
Yeah.
So to me, I had that a few times where you just basically talked so much. So in that case, again, I already said it, you go off on random tangents. You could have said, hey, I'm just caching the along 2 dimensions, the index I'm looking at, and the total amount of sum that I have passed in. You could have literally just said that and then just written the code. But instead you spent 5 minutes talking about him. It doesn't make sense. It's there's no reason to talk about it. Why does it need to go into so much detail?
Okay, can you say that again? How you explain the caching thing again?
Sure.
I just caching along the index in total?
Mm-hmm. So it doesn't matter how many different ways I get to index 7. I could pick index 0 and 3, or index 2 and 4 in my set. It won't matter, because eventually I will get to a total, right? And that is the state I can reuse. I already know that there is at least one path to the index I'm passing in, or the index I'm looking at, and the total amount of sum that I have accumulated, or in this case that you have reduced, because you're going backwards from, not from 0 to the target sum, but from target sum to 0. So I can reuse that. If I've already calculated it.
Okay.
That's the way I would explain it, and then I would just plug it in here and plug it in there, and my lazy ass would just say record in 2D cache, and then just say index, and then sum. Or I wouldn't call it turtle. I would call it curse sum instead. But
okay, yeah.
You get the idea. And within 15 seconds, the interviewer already sees the exact same thing. Remember, it's about being efficient with your words. The more efficient you are, and it's just enough to cover the subject and keep them following what you're saying, but short enough that they don't get bored out of their fucking mind.
Yeah.
So
I think generally I would bore my interviewers with how much I talk.
Yep. And also be really careful about what the heck you're doing and talking about. So. So anyway, yeah. Let's see. Let's go to the next problem. Oh yeah, red tape, blue tape. I haven't given you that one. I like giving that one. Alright, so let's start the timer again. Hold up, I need a fucking beer. Give me like 2 minutes.
Yeah, no worries.
Wait, damn it, where's my fucking beer opener? Oh, there it is. On my freaking desk, like I'm an alcoholic, man.
Jeez.
I have not been sober. I wasn't sober yesterday. Yeah, I don't think this entire week I have not been sober. On a first single day.
Jeez.
It's fine. It's whatever. I mean, to be fair, the after parties, they give you like free booze and shit, so whatever.
Damn, that must be nice. Yeah, Joy-Con must have been hella fun then.
Yeah, I mean, we can talk about it afterwards, but I highly recommend people go to these conventions and really just as network and also attend the talks and kind of get a sense of what's out there. So, anyway.
Yeah, for sure, yeah.
With that, so given a red tape and a set of blue tapes, a tape is an interval XY, right? First stick the red tape on a table and stack with blue tape. Determine if the red tape is visible. So for instance, if I gave you 3, 6, and then the blue tape's 1, 4, 5, 8, the output would be true because there's a red section visible between 4 and 5. But if I were to have like blue tapes 1, 5, 4, 8, the output would be false because red is not visible. So let's have it.
Okay. First thought is let's do the examples thing again. Let's visualize these tapes as actual tapes, like line segments sort of thing. So let's have like a number line. For the first example, I'll type it out. So I see it's 1 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. You can see one over here and another one coming over here. Actually, let's just use characters to signify.
Sure.
So B over here, B over there. Another one on 5 and another one on 8.
Sure.
And now here comes the red. So 1, 2, 3, red and.
I'll fix this a little bit for you so it's a little bit clearer. But yeah, I know what you're doing.
Okay. So you can see in between here 4 and 5 that red is visible, that tiny little gap there. So let's figure out how we can find that tiny little gap. So first thought is, are the blue tapes you're giving me in sorted order, and like any sorted order, like sorted by start times or end times, or there's like
just
random
assume that they're random.
Okay, so I think it's a bit easier. We'll just sort it by start times then. So to make it easier, so idea, sort the blue tapes by starting time. It says giving a red tape, so I'm assuming you're only giving me one red tape.
Okay.
And there's not going to be like let's find out how many possible ways the red tape can overlap with the current blue tape. So we have over here, I'm guessing red tape. Will red tape indices always be within the blue tape endpoints? So what happens if you get? Will a valid input be a red tape of maybe say 3 to 9? Then
okay, that's is that a red tape?
Yeah, that's red tape. Yeah.
Yeah. So if that is the case, you will still see you'll see a gap between 4 and 5. So. And then
Yeah.
also,
Okay. Yeah.
And you also have to see it at the end here too. So.
Yeah. So what happens if the gap was covered up? So pretend we have equal blue. So will 9? If I have 9 over here, but it's not included in the blue tape, then is that okay? Like that's still a valid input.
Well, if you covered this up, you still have red tape poking out here.
I mean, I have red tape. Yeah, I have red tape poking out at like the end of 8 to 9 is where the red tape pokes out.
Yeah.
Okay. So yeah, okay. So that's also valid. Okay. So generally, the intersections I can see from these line segments are if the endpoints. So let's snap it up. And endpoint of R is after all blue tapes. Yeah, that's really it. Endpoint of R is before all blue tapes. I should put start point instead. And then there's the middle section of middle point somewhere of R is in between blue tapes. So those are the three instances I can see from how all they intersect. Generally, an idea I'm thinking of is we can just merge the blue and the red tapes together.
Okay.
So it can be like 1 4, 3 6. I'm assuming I'm just gonna sort them by start time to make it a bit easier. So over here, generally we can see if, and now we generally check. Oh, is there a point that's not covered between the endpoints, sort of thing? That's also covered by the middle point. So
okay.
If 4, like you can see over here, 4 and 3 over here, like, oh, hey, you know, that's covered, right? Endpoint, it's the endpoint and starting point. I guess, like that.
Okay.
So 4 and start point. So yeah, you can see over here in the first case, 4 is bigger than 3, that's okay. But you can see in this case over here, that's not really too well, right?
Sure. All right, let's. I'm gonna do one thing.
Yeah.
What do you think I'm about to say right now?
Rambling on.
More specifically.
How does this advance our discussion?
Yes. How does this get me closer to a solution?
Yeah. Okay. So the point of how I'm trying to explain is getting ideas of how I can find that there is a gap between the endpoints of the blue tapes and see how see if there's a gap anywhere between.
Okay, but all you've been talking about is merging blue tapes. You haven't talked about finding the gap.
Yeah.
Even if we merge all the blue tapes, we still have the base problem to contend with.
No, I merged the red tape with the blue tape.
Okay, you're merging red tapes and blue tapes together. Okay.
Yeah.
Why? I don't get it.
Because now they're all in like one simple array I can iterate over.
Sure, but how do you know which one belongs to the red tape?
I mean, in that case, we can just see if there is, and okay, I can see if there's a gap somewhere in between the tapes, but I can see that we need to differentiate now between.
Yeah, why do we need to put them in the same array? That doesn't make sense.
Yeah. Okay. So let's go back to a little bit first principle sort of thing. Okay. Let's see on interval stuff we can do. So what happens if
Well again, I'll let you run off with this for another few minutes and then I'll interject. Keep going.
Okay. What happens if we merge all the blue tapes together? So, 1 4 5 8, that's one total valid solution. And now we check if the red tape start point is within the endpoints and start points of all our intervals. So in this case, mapping out an idea, we can check if the indices is 4. We can check if the start point of the red tape is less than our blue tape, or bigger than the next tape and start point. Let me just map out like possible combinations, and then I can explain it a bit better, because then I'll get a better intuition on how it is. So for 3, that's valid. Then we go for 9 and 5. I know there's some like an intuition. We need to compare the endpoints between the endpoints and start points of the blue tapes with our red tape. So for 3, 4 and 3, yeah, and 9 and 5. Let's point over here. So 5, let's put them all in one section. 4, 5. You can see that that's a bit bigger. That is not. 4 and 3, that's somewhat on there, and 5 and 9 is slightly less. Finding a intersection. I mean, I'm trying to find the gap, so as soon as I can find where, as soon as I can find an endpoint and a start point of 2 blue tapes where the red tape overlaps, then there is the point that red tape is visible. So 4 is bigger than 3, yeah, and 5 is not bigger than 9. I guess that could be our condition then. If start point is less start of B, end of B is bigger than start R, and start B is less than end R of indices after the first.
Okay.
Let's test this again with just the first. Another example to be sure, though. Let's have the tape be 2. Let's have the red tape be 2, 6, and the blue equals is 3, 6. Just 1.
Okay.
Like a simple. You can see that the end of B is bigger than the start of R. So it follows this case over here, but is the start of B less than the end of R? That's also true. I guess you can say then that is then red tape is visible if these conditions run true.
Okay, so if the end of the blue is greater than, yeah, okay, sure.
Yeah.
So then how does that help, again, so how does that help you solve the problem?
So essentially what we do is we merge all the blue tapes together, and then we check if any of these conditions are true, and if it is, then the red tape is visible.
Okay. Sure.
Because we need to minimize the amount of blue tape. We just need to minimize the amount of blue tapes we need to check.
Okay, fine. What's the runtime of this solution?
The runtime of the solution, so basically we need to merge all the intervals. That would be O of n to merge the intervals. Then to check with check the red tape against all blue tapes, that would be another O of n. In the beginning, we do have to sort the blue tapes by starting time, so that would be n log n. So
okay. Our
final runtime would be O of theta n log n, average time, whatever you want to call it.
Okay, can you get faster?
Okay, can we get faster? That means we do have to get rid of the sorting. So how can we get through this? So an idea is to mark the endpoints and start points of every blue vertex and red point, I guess. So to make this a bit clearer, so our endpoints would be 1 and 4. What am I saying? That's just blue tape. So basically, we keep track of our endpoints and set those to a 1. So to make this a bit clearer, the endpoints will essentially be the range of our whatever you call it, our total range of tapes. So in this case, it would be 0 to 8. So once we find an endpoint, the start point, anyways, we increase it by 1. Okay. And once we find an endpoint, we decrease it by 1. Same thing over here. Okay. Increase it and then decrease it. I added a 9 in here, so that's gonna be a bit different. Okay, let's remove the 9 and go for the actual example. The diagram was messing me up a little bit. Sure. So yeah, that's it. And then the red tape essentially is 1, 6. And now essentially I feel we need to match these anytime we have anytime we have a interval, anytime we have a value of a certain number, then the red tape is visible.
Okay, what's that certain number going to be? I don't know what your
I think the number would be 2, because that indicates we have two starting points that we have entered.
What if there are some blue tapes that overlap then?
Yeah, so in that case, we would run the merge intervals first.
Well, again, you're sorting, so that gets you back to n log n, doesn't it?
Oh yeah, okay, so there's no merging. No merging. So, okay. Let's try out the example over here, sure. Right? See what happens. So 1 plus 1, that's 2. That means we entered the blue tape and the red tape, and then once we reach index 4, we minus 1, so that'll be 1 over here. Then plus 5 again. So that would be plus 1. Yeah, that would be 2 again, and then we negate by 1. Wait, yeah, okay. Yeah, 2, negative 1. Yeah, 2 minus 1, then we plus 1 again for 2, then we minus 1 again, then we minus 1 again. So that equals to 0, so I don't know where I was going with that. We need to find that the numbers between 4 and 5 is a good starting point. So, but that equals to 1, so just map it out again. That equals 1, and starting at 4, 5, that is 0. 2 again. So, how do we find out there is a visible tape between the blue and the reds? So we know already that if there's overlap intervals, then the number will increase because we started many start points.
Okay, but again, what happens if your blues overlap?
Yeah. That was the situation I was describing.
Okay.
But yeah, so to make it a bit easier to visualize, let's have an overlapping blue case in here. Okay. So 2 to 3. So 2, 3.
Okay.
Yeah. Okay. Yeah. 5. Oops. Okay, so how will this all work out? we need to find a key point to look at is between 4 and 5 and see how we can relate that to other points. I mean, we can always check. No, not always check, but an idea is in between 4 and 5. Yeah, no. If in between 4 and 5 is, we can check in our, no, we have to use a sorting algorithm for that, because again, I'm thinking of merging intervals, so that's not a valid solution. I do think an optimal runtime could be using 5. An optimal runtime would be O of n. So let's apply the. Let's try having a vertical line sweeping left to right between our array. So if we have a vertical line left to right, sweeping left to right, then it first would encounter the 1, then it would encounter the other 1, and then after that, for just blue lines, no, not blue lines. So, and then it would counter a -1 because then we enter the red line, and then after that, it also encountered another endpoint, which is the endpoint of our overlapping one. It also encounter another +1 because that's a blue, and then again, I think I messed myself up. Yeah, and then 5, -1, -1. Technically, this all equals to 0 anyways.
Okay.
So I'm not sure where to go with this right now after trying out these examples. 1, 2. 3, that's a valid point. 4 and 5 is a key point to look at, but at that point we don't really know whether it's an intersection that's not visible by the blue tapes. We can see if it equals a higher number, then the higher number is not valid. A higher number than 1 is not valid because there might be the instance of overlapping intervals, which increases the count to above 2. Negative intervals really wouldn't work because we know it has to equal to 0 if the tapes actually do end properly.
Okay, how about this? Since you're like going in circles, just code up your naive solution that you saw worked.
Okay. Naive solution was essentially over here. Merge intervals. Sort intervals by start time. Merge intervals after merging intervals. Check NB start R and or start B end are true. If it is true, return red tape is visible. Otherwise, return false at the end.
Okay.
So return true. Otherwise, if entire array is traversed, return false. So, you know, start time is generally okay. The merge intervals is a bit tricky because now I have to find out how to merge 2 intervals. So generally, I think if the endpoint is less than or equal to the next interval's start point, then merge. Qualify to merge. Let's test it out really quickly. 3, 6. And 5, 8. The end result should be 3, 8. Let's see if that works. So, you can see over here, the end of our first one is 6, and it's less than. Okay, so I tried that out. That doesn't really work. But if it is like this, then it does work. less than or equal to. If their endpoint is greater or equal to the next interval start point, then is it qualifiable merge?
Okay.
Yeah, generally you go through that. That's generally the same situation. So iterate through entire array, iterate through entire array, and then do this part essentially. After do that part, yeah. Qualify to merge. So make new interval with new start point and end point. Next intervals endpoint and new previous start point. So yeah, make new interval with previous start point and next interval endpoint. There's also the case where we have multiple overlapping intervals. So in that case, we just do a while this is true, essentially, instead of just an if. Or we can do an if statement that keeps track of the start and end. But let's go through it. So let's define the intervals. So let's define the high-level algorithm, which is red tape visible. We have red tapes, we have blue tapes. So let's sort the blue tapes. So, you know, I just sort it. We have a lambda in here. This is just x0. That just tells us to start by start time. Sort it by start time. Now we do a merge intervals algorithm. We'll find that later. Overwrite it because that's going to be our new. It's going to be our new blue tapes. And now that we just check if the end of B is at start of R. So for start B, end B in blue tapes. Basically check if end B is bigger than start R. Let's define start R over here. Red tapes 0 and end R to be red tapes 1. Well, technically it's only one red tape, so it doesn't really matter.
Okay.
Start B less than end R. Return true. Return false. And now we have time to implement the merge intervals algorithm. So blue tapes. Let's just do tapes. Make it a bit easier just in case we want to merge something else in the end. So, you know, if not tapes, really don't really return anything, really. So now we check if it's qualified to merge. So iterate through entire array. Yeah, let's do new intervals. So we iterate through the entire array. So for I in range, and no, let's just do that. Tapes. So iterate over the entire array, qualify to merge. While let's go n equals tapes I. Next interval start point. So over here, to stick to our algorithm, we need to have a start point of tapes 0 0 1 over here. So yeah, and now if n is equal to next interval start point, new intervals append it, we add it. So start end, we need to update it now to because obviously we need to, because we can't reuse the same start and old, so tapes I 0. No, that would give us a bug because we already appended the current ones, so yeah, we do need to update it though, so well, and here we go. Make new interval with previous start point next. Yeah, that's generally an I. So to do that, we do need to make it a loop. Tapes equal 1. So yeah,
Okay.
over here now, start and end equal tapes I, and you know, after that increment it, and we go through the entire process again, and we should return new intervals. And that generally I think that should be our new merged intervals, and then that's the algorithm.
Okay, let's see. I think there's a pretty big mistake here, actually. What do you think that might be?
Part? The merge part?
Well, I'm asking you.
Oh, okay. What do I think the bug might be? Okay, I think it might have to do with merge intervals. I might have to look into that a little bit more. Let's see, for the general high level idea though, if the algorithm is right, so NB star R, we sorted by start time, so let's try it with this array first. So what happens if red tape red is equivalent to 3,6, and we have blue equal to, let's try the overlapping interval section, overlapping session 5, 8. So that would turn out.
You have another bug as well. Yeah, just keep going.
Yeah, okay. That would be generally going to 1, 4 after merging 5, 8. So that would end up with the original one. We can see over here that our condition of check end of B, so that'd be 4, less than start R, so that'd be 3, or B, or 5 less than R, less than 6. So that there is one bug with the traversing of the tapes over here. I'm not considering the next index and the previous index. I need to keep track of my current ones, so start B equal, so I definitely need to fix my for loops sort of thing. So while I in range, well, I less than length blue tapes, I equals need to start to 1, start B equal to blue tapes 0, and B equal to blue tapes 0, 1, 0, and now I go for this. Yeah, that's true. Now we need to NB equals NB and start B. Yeah. Okay. NB needs to be the next boot tape. So NB needs to be the next one. Start read equal boot tapes. I 0. But that just updates it to the current ones. We need to make sure we need the yeah.
This doesn't change anything really fundamentally, and you still have issues.
Yeah, I mean it was a loop error.
No, you still have another issue going on.
Yeah, a more logic error, you mean?
Just more bugs.
Yeah.
Alright, you know what? I'm gonna stop the timer here because you've taken up basically 35 minutes.
Yeah. Okay.
So anyway, what do you think you did right? What do you think you did wrong?
I went into circles in the beginning of while I was getting lost on the optimization of the algorithm.
Why?
Because I was basically reiterating what I currently said, not really making any progress towards the actual solving of the problem.
Yes, but you're describing what you did, but I'm asking you why you did it.
Because I didn't really understand what I was doing to get to the solution.
Okay, so
I had an intuition somewhat, but trying to find out that intuition is a little bit harder, so I just kept repeating myself.
So basically, you had no idea. You had no logic. That's basically what you're saying.
I mean, I was trying to find the logic with but it wasn't happening.
Okay.
Sort of thing.
Okay, you know what? For the sake of time, I'll tell you exactly what happened. I don't mind you doing this. I just don't know where it came from. This was you doing magic bullets. That burned like from 12 minutes to 20 minutes. This is you. You had no idea what you're doing here because you had no idea where this idea came from. And
I mean, the idea came. Well, the idea, like, just instead of sorting, we would mark the start points and end points of each tape, essentially. But
why is that? Why did you jump there? Let's ask that. How did you go from your current solution, your current naive solution, to that one? What was the logic?
Because the logic was, since we are checking the end tapes and let me highlight it. So since we're checking the end of B, with the start of R and the start of B with the end of R, maybe instead of sorting, it would automatically sort it for us already if we mark the endpoints of.
Are you hearing yourself?
A little bit confused, yeah.
There you go. That already tells you everything. It's like maybe it sorts us, but how can you sort it without running a sort? Is there any algorithm out there that sorts things automatically for you? And if it did, would it beat the n log n runtime?
Yeah, I mean, n log n is, for comparison sorting, n log n is the best.
Basically, what my point here is that you pulled this out of thin air. Now, this is not necessarily wrong as a technique. The start and end plus 1 minus 1. That's not wrong as a technique. Okay. The problem is that you have no justification for going there. Now, if you said that, hey, the only thing we care about are the start and end points of the interval, it's like, okay, I can understand where this is coming from. But in this case, not necessarily. Now, the exception I would have made for this is that, okay, well, instead of looking at the tapes, why don't we just look at the indices they span and just iterate through that? And then you can do like the plus 1 minus 1 thing. That would have also been a fine answer. That would have been an acceptable answer. But you just threw this out of nowhere. That's the difference.
Okay.
This is what we call the magic bullet. And you threw a magic bullet where it has no connection to what you previously thought. That's why you screwed up here. That's the first screw up. Do you know what the second screw up I'm going to talk about is?
So the first screw up was the magic bullet.
Yes, this idea came out of nowhere.
Yeah.
And had no bearing on your previous ideas.
Okay.
What do you think the second screw up is?
So the magic bullet, I think the other one is either rambling too on and not testing enough for the high-level algorithm.
It's somewhere in there. Let's be a little bit more specific.
So I glazed over too much on how to do intervals, and I should have tested the conditions a bit better with more examples.
Closer. Let me tell you, it's this condition. This condition is just completely wrong.
So yeah, okay, the merge intervals. Yeah, okay.
You just tried describing your idea, but you never tested whether or not your idea was actually going to work.
Yeah.
You kept like you spent way too much time just like it's like kind of like meandering through this. Like again, like merge intervals. If you can do this correctly, that's fine. And so the basic idea is fine. It's just that it's wrong. You didn't need to spend so much time on it. And then afterwards, what I have another problem with is that you basically tried solving this by throwing more more variables at this.
Yeah.
I don't. It's like more variables does not make it more readable. In fact, a lot of times it makes it less readable.
Yeah. I think my intuition, my reason for that was because I needed to somehow get the next interval start point while still being on the current interval. So that was a bit.
So, but the thing is that your intuition's wrong. That's it. It just means. Yeah. Why do you have to get the next one? Why don't you just compare? Like you said, let's look at your idea, right? Let's sort. Let's bring this down here just for the sake of readability. So you're gonna sort the intervals by start time, merge intervals together, and then you're gonna iterate through the array, and then okay, this is how you describe the merge intervals. So then check at the end. You should then this is the point where you say you have to iterate through all the blue tapes, and then for each blue tape, check the end of B, start of A, start or true, return true.
Yeah.
What's wrong with just doing this?
What do you mean?
What's wrong with just following this formula? Why do you have to fucking add this shit?
Yeah, no, cause when I said this, I was meaning the start of the next B tape.
Why? Why can't you just use the current B tape?
I mean, let's cause when testing it out, it was like doing a crisscross comparisons rather than comparing like the lines for comparison crisscross, so that one didn't seem very logical.
I don't understand what crisscross means.
Okay, so over here in the higher level, so for red and blue tape, we're comparing 6 and 3.
What? Okay.
And 2 and 6.
This is the red tape, and this is the blue tape.
Yeah. So
why start 6 and 3? Start interval from 6 and end with 3.
So red, blue, red, blue.
You could have. I would have. If you asked me about this, you could have said, "Hey, are the intervals increase like from smallest to largest?" You could have asked that, and I could have said yes.
Well, what do you mean? We already sorted it, so it's assuming.
So where's 6 and 3 coming from? Because you have 3 and 6 here.
Yeah. So red tape is the first index. So the first red tape over here, we're comparing to 3 over here.
Okay, so you're starting. You're comparing the start and why would you? Okay, so my question is why this need to begin with?
Yeah, I was saying that was a bit like that's not logical. So we should be comparing like 6 and the next 3 over here.
No, and I'm saying that's illogical as well. You're doubling down on this bullshit. What happens if there's only one tape?
Then we only compare the ends. We only compare one part. So start of B and end of R.
What if I have this? What if I have this situation? How does your algorithm work then?
Okay, yeah, there was a bug. Yeah, we do only need to compare the end of B and the end of R then you can see. No. Yeah, I mean it's overlapping, so it becomes a bit.
The thing is that my point here is that you're overcomplicating it. Start with a very simple example and solve the very simple case. Just solve the problem. That's kind of the theme of the problem that I saw. You didn't try solving the problem. You tried overcomplicating it. You tried solving some random like additional case when I could have just presented you, hey, why not just solve the individual case? And that's it. Just solve the damn problem. You're not solving the problem. You're just trying to over-optimize.
Okay. Yeah.
You understand what the difference is?
Yeah.
Like when you're merging the blue intervals, my question then is, how does that get you closer to the problem? Get you to solving the problem. How does it get you closer? That's the question I want you to always ask yourself. Does this get me closer to solving the problem?
Yeah. Okay.
And so this crisscross thing is just bullshit. It's straighten up. There's nothing else to say because by doing that you are missing out this first index.
Yeah.
if I only had like one piece of red tape and one piece of blue tape, it will you will fail this case. And it's a very simple case, and then you have to overcomplicate your code just to fix the one very simple case. And that's basically what we call nightmare situation. Second,
what?
Nightmare situation.
Oh, nightmare. Okay.
You're solving the complex cases before you're solving the simple cases. That's not logical. Solve the easy shit. Second one, this one. You didn't test this. You tested it, but it was a very weak test. You remember, you need to think about all the different ways that this shit can go wrong.
Yeah, I should have reiterated on how intervals can overlap and then solve all those.
Yeah. So in other words, this should have been actually overlapping and merging intervals should have been automatic. That's a pattern from grokking.
Yeah, I haven't touched that in a while. Yeah.
No, it's not that it's even if you didn't know it, it should be very plain simple. Hold up. Let me actually do this. So if I was gonna do like the merge intervals thing that you did here, let's say I was gonna do it. I would start with some pseudocode like merge intervals in a, let's say, list, right? So I would do my pseudocode like, okay, well, I'm going to iterate through I'm just going to have like a new list. Create a queue, you know? I create a queue, and then iterate through the, and then add all elements from list to queue. You know, I'm assuming it's all sorted, right?
Yeah.
So iterate through the queue, and then iterate through the queue, pop, compare to previous elements in queue. And then I would say something like if intervals overlap, and then I would say combine the intervals and push back in the queue. Otherwise, if they don't overlap, add the previous interval to the list, and then assign previous interval to previous interval, something like this.
Okay.
Do you understand why this would probably work? And then I've tested, of course. But basically, it's just me trying all that, and then I would just sort it again, you know? This is like me doing it at a very high, quick level. I would need to double check, and I could probably optimize on this. But you understand, like, how I'm just doing everything step by step.
Yeah.
I don't have your two loops bullshit. Mm-hmm. And of course, I can always clean this up and do it better. But this should pretty much work.
Okay. Yeah. This is for a merge interval. Yeah.
I mean, I can do your two loops bullshit as well, but as I would prefer not to, just because like this is a little bit more intuitive and easier for me. Because then I can. Yeah. Because then I always sort the list again.
Mhm.
I mean, but either way, my point is that it should be simple, easy and methodic, right? This is what you probably needed to do in order to handle the merge intervals.
Mhm. So handle the merge, yeah.
So in other words, there's a lot of mistakes, but it just kind of boils down to not having a clear idea. Your pseudocode, in theory, if you were competent, would have been enough. But I think it just underlies that you can't translate. Is like you are not. I would say you're not competent enough to translate your pseudocode to actual code just yet. So you need to be a little bit more detailed. And this is where like you tearing into your own practice diary. If you looked at your practice diary, it's like the pseudocode is fine in theory. But is that you need to have the ability to translate all this into the details that you need.
Yeah, and I'm not at that point yet.
Yeah, you're not at that point yet. So, in other words, you need to go back and maybe dig into like the translation between your pseudocode and actual code. I'm actually more surprised we were able to get away with it for so long. But now I'm kind of seeing, now that I see you executing on this, there's definitely a lot of issues. So. Okay, yeah. So this is what in your practice diary, you need to be very, very meticulous about like, hey, is there like some how long does it take for me to code, and does it match my my pseudocode?
Yeah. So I feel like generally as I do more problems of a certain pattern, like as for the DP, and then I generalize a little bit. But if I'm doing a totally new problem, I need to be a bit more detailed with everything. Yeah, it's like I'm not sure this works. What can go wrong? Yeah. That's what you really need to ask you. It's like, are you sure this idea works? You know, I came up with like some basic solution, right? But I'm saying, hey, yeah, this might not work because I have like, you know, I'm pushing back in the queue, and then if I keep adding intervals and stuff, I might need to resort it or some shit. You know, I'm acknowledging, hey, this might not be perfect, and you know what, I'm ready to test it. I didn't commit to it. I'm like, now that I have the outline of it, I'm like, hey, let me bulletproof it. Oh yeah. So you need to have that attitude. It's like, what if you're wrong? Mm-hmm. So let me have that. Yeah. I get what you mean, yeah. Bulletproof your idea before coding, and make sure your idea translates to code. So.
That's basically the feedback for you, and then also like no magic bullets, logical, what's it called? Logical derivation of optimization.
ELI 5 derivation for doing it. Why? Because I think the logical derivation I do it are making it too complicated, which makes it really dumb to try that idea essentially.
Yeah. So in other words, you ramble too much. You talk yourself into believing that the idea works when all you've done is, like I said, nothing. You know, it's like the people who trick themselves. And so you need to be much more efficient with your words.
Okay, yeah. But has the rambling gone down a little bit though, or is it still like?
It's gone down a bit, but you still end up having that habit. So the so the thing is that you need to check yourself and really make sure, like, hey, every single word I say needs to mean something.
Okay, yeah.
I mean, M had that problem before, but it took me like a few weeks for me to harp on that and for him to finally get it. But yeah, the exact same problem. If you want, you can actually. I would say chat with him in the server, see if he has any tips for you. Show him like the points that I made in the prep doc. See if he has anything for you. Maybe he did something to help fix it. But the point I'm trying to say is, hey, you got to fix this.
Yeah.
Well, that's pretty much it for me. Now, as far as your homework goes, it's kind of hard because you've done quite a few problems, and you're still kind of have this like problematic translating your idea into code sort of thing.
Yeah.
It's weird.
Yeah, I thought I got better at it, but it seems like I'm still.
Yeah, it's like whenever you're practice diary, it's fine. But I feel like part of it is that I know what I feel like when you look at the section in the book, you kind of like have this preconceived notion of what you need to do, like because these are arrays. I know how to use arrays, and I already have the preconceived notion of what my code should look like. That might be biasing you.
Yeah.
But also, I've noticed that you don't take a lot of detailed notes in your diary. So, and I feel like you're not being as critical as you could be.
Okay.
Because I mean, this has been problems in previous weeks, and I think it's showing. So it's like every little mistake you make needs to be harped on, but also like if you feel like there's some translation error between your idea and code, that also needs to be pounced on and looked at.
Yeah. I mean, sometimes when coding, I do end up changing the design a little bit as I go through the code part. That's not too good.
Yeah, so look at when you change your idea. If it needs to be changed after you committed to it, you didn't plan something. Then what test did you miss? So that's I'm gonna say go back and look at that. If you look at the problems that you had to change the test on, or change the idea on, and say, hey, why did I miss this test case? How can I bulletproof my idea?
Yeah. Well, I mean, generally, isn't it like to bulletproof the idea is just more tests?
No, it's not more tests. Because remember what I think I mentioned this in previous streams. There's a difference between like doing random bullshit tests that don't.
Yeah, like actual tests, like what happens if it acts on a sorted array? What happens if it acts on a decreasing?
Well, the thing is that you have to think about all the factors that can change here. So remember how I said one of the first things we talked about was proof by cases for a tree.
Yeah.
It's like if I can handle every single one of these cases, then I've handled all the realms of possibility. And once I've handled all the realms of possibility, I know my code is bulletproof, right? In this case, the key trick would have been to make sure I can test all the different ways red tape and a single red tape and a single blue tape can overlap.
Yeah.
That's that's what can go wrong because the branching factor. So that's.
Yeah, I think go first.
No, I'm going to say that. Yeah, that's basically what you need to think about. What are the places that can go wrong and test there.
Yeah.
Okay.
I think what you said for the blue tapes and red tapes. I think I did say that, but I didn't test it hard enough. Harp myself hard enough on testing it.
I mean, you need to be super giga hard on yourself right now. It's like even in practice, you need to be like every single thing that might be a mistake should be scrutinized.
Yeah.
Like have you read the book Relentless?
I'm on it. I'm like on. Let me check my book. I think I'm on like page 33 as of at this moment.
I mean, you can knock that out in one night. I think you should probably. I would recommend you try to like finish it if possible. Like really get a sense of Yeah, like page 33 is like fucking chapter 2 or 3 in.
Something like that.
Yeah.
Yeah.
I'm gonna say finish the book tonight. That's kind of like it'll give you a little bit of an attitude check, and it'll show you like what the work ethic you really need to have is in order to to look at your.
I mean, I don't think I can bang it out in one night, considering it's already the next day.
That's
but
true.
I will...
You get the idea. Yeah, but like try spending a day on it, and really drill your own mistakes.
Yeah. Okay.
So, all right. Is there? I think that's it for me. You have a lot of things to work on. Your homework is going to be just keep. I would say if you've gotten done with the all the problems in EPI, which I'd be surprised because you did 100 problems, but I think there's more than that in EPI. Start going back and redoing some of the problems you found problematic.
Okay. Yeah. What do you mean by all problems EPI? You mean all problems in the DP section of EPI?
Well, I mean, you have a little bit of section. Oh yeah, you do have like some DP issues. So do the DP problems in EPI and keep in mind all the stuff we talked about. Or if you're not done with grokking, do that. But
yeah,
don't throw away your fucking ideas.
Mm-hmm. Yeah, don't throw away the memorization. Yeah.
So try to actually first redo some grokking problems with that in mind. See if you can get the translation going between your naive solution and optimal solution.
By grokking, you mean grokking the coding interview?
Grokking the dynamic programming interview. Then try some EPI dynamic programming. Then after that, go back to EPI generally.
Okay, but like what chapters of EPI generally?
I would say probably go back to like arrays. I would say go back to array lists because for some reason, because this was a very simple problem, and this didn't even fall under recursion.
Yeah.
Actually, you know, recursion. I've already kind of given you the blueprint for that. Yeah, I guess go back to array or something. It's hard for me to say.
I mean, there's still sections. There's like there's a searching section, a heap section.
Okay. Yeah. So do those. Just keep progressing through the chapters as laid out in the book.
Okay. All right. That works. Yeah. Sorting. 3D. Yeah.
Okay. So that's it from me. Do you have any other questions?
I think that's it. Redo some grokking DP. I'll generally start with that. Finish it first and then redo some of them. Then EPI dynamic programming, yeah. Then EPI generally keep progressing.
Mm-hmm.
Then relentless, yeah.
Yeah. So that's gonna be yeah. So if that's the case, then I'll let you go. I know it's pretty late. But yeah.
Yeah.
We got like
just to prioritize the stuff. So maybe relentless should be like priority 1 then.
I would say read it like when you have free time. Like I think you have to commute to work or like school, right? So read on the bus.
Yeah. Okay, yeah, sure. I'll bring those around.
So that's it. Yeah. Get some sleep, man. You got a lot of work ahead of you. You got like 2.5 weeks till your interview.
I think it's. Let me check. I think it's 3 or 4.
Okay, really? What date is it?
June 26th.
June 26th. Yeah, so 26. You have 22 days. You have 22 days.
Yeah. Okay. Yeah.
Yeah. You don't have time to waste. You gotta really hammer home on the practice. Be self-critical.
Yeah. Okay. Yeah. I'll hopefully get most of the problems fixed by next time we have this coaching session. But we'll see.
No, it's not like we'll say you need to do it. Yeah. It's do or die, right?
Yeah.
So.
Yeah, for sure. Yeah.
Okay. Anyway.
Okay.
All right. I'll talk to you later, man.
Yeah. Thanks, man. For helping me out.
Yeah. For sure.
Yeah.
All right.
Cheers.
Cheers. All right. That's it. Any comments from the crowd? Non-overlap is max start B, RB, min, NB, RB. Yeah, that's true. So he's like, that's the answer, but the thing is that you have to figure out how to do that. And that's the step-by-step I'm trying to work on with him. Try to see red not totally inside blue. Yeah, lost in the wood. He needs to find where to insert and check two ends of the blue. Yeah. So basically it's a question of overlap. And so how do you test for overlap? You know, and all he did was just check the end, and all he did was check end. But you need to be able to check more than that. And the overall attitude for the approach is, what if I am wrong? Like, there's a good saying, remember? Like, I want to know, the Charlie Munger saying, where I want to know where I'm going to die so that I never go there. It's the exact same thing. Anyway, Any other questions from the crowd? I mean, we have a few minutes. Otherwise, I'll turn off the stream. I'll be happy to answer any questions you guys got. Dota's on. I'll give it like another minute or two. See if anyone is like being silent in the crowd. Going once, going twice. I mean, I guess there's not really anyone else. I guess people are leaving, so you know what? I guess I'll turn off the stream. Thank you all for joining me. We will have a coaching session, I think next Tuesday, where we'll do like some replay analysis, and we'll be looking at some of the diary entries, and hopefully we'll be able to make more progress there. So with that, thank you all for joining me. If you guys want to have any questions or you want to follow me on socials, links in the description down below. If you guys want coaching, you can book me for interview coaching at eachhandtech.com. Otherwise, have a good night, and I'll see you all next time. Thank you all for joining me.